Last example for this series, we're going to find the radius of convergence for 6 over 3 minus x. So remember, we're trying to get something that looks like 1 over 1 minus x, okay? And that's going to be your standard 1 plus x squared plus x cubed and so on. Okay, so a couple of things here. We can factor out a 6 from the top. We could factor a 3 out from the bottom because I want to make this a 1. Okay, so I'm going to factor a 6 out of the top. I'm going to factor a 3 out of the bottom. If I divide 3 out of the bottom, that's going to become 1. This would be divided by 3, so it would be minus 1/3 x. Okay, so that's our setup here. So does everybody see? This is the same thing as this. You multiply by 6 on top, you get that. If you multiply by 3 here, you're going to end up with that, okay? But now, we've got 6 over 3 is just 2, right? So our whole series is being multiplied by 2. I have 1 over 1 minus the input. So instead of having x as each of my values here each time, I'm going to have 1 over 1 minus 1/3 x. So 1/3 x to the first, 1/3 x squared, 1/3 x cubed, and so on, okay? We need to put this together and get our actual series here. It's the sum from n equals 0 to infinity. All right, a couple of things here. No alternating terms this time. Everything's going to be positive. You can see that through here. Every term is being multiplied by 2, okay? So you could put the 2's in here, or you could just do this. Remember, the normal setup for your standard 1 over 1 minus x is x to the n, okay? My input, instead of being x, is 1/3 x. So I have 1/3 x to the n, okay? And then this whole thing, each term is getting multiplied by 2. So you could say I have 2 times 1/3 x to the n. I would probably rewrite this. This is x over 3, and it's being taken to the n. And so you could actually write this as x to the n, sorry, x over 3. X to the n over 3 to the n, and then the whole thing's being multiplied by 2 is probably how I would write it. So I'm going to rewrite it as 2 times x to the n over 3 to the n. We're going to write the terms like that, okay? And I think you should see, if you start substituting values of n, you should end up getting the terms of this sequence, okay? So now, what are we doing here? We're applying the ratio test to figure out when does this function actually, when does this series actually model this function? What kinds of values of x can I put in which this will actually be replicating that function, okay? So we do the ratio test here. We take the limit as n approaches infinity of a sub n plus 1. Now this is interesting. Our individual terms are already fractions, okay? So this is going to be a little messier. The n plus 1 term here, both of those n's are going to become n plus 1. So we have 2x to the n plus 1 over 3 to the n plus 1, okay? And now we divide by the nth term. This is the nth term, so we get 2x to the n over 3 to the n, okay? And we're taking the absolute value of the whole thing. That whole limit needs to work out to be less than 1 for convergent values. Now, a fraction over a fraction, horrible setup. Okay, but remember, when you divide by a fraction, you multiply by the reciprocal, okay? So I'm going to rewrite this a little bit. I'm going to rewrite this to multiply by the reciprocal inside my absolute value. So I've still got my 2x to the n plus 1 over 3 to the n plus 1, but I'm going to multiply by the reciprocal of that denominator, which will be 3 to the n over 2x to the n, okay? And we can try to simplify this whole thing. Everything's being multiplied across the top and bottom, so you can kind of move things around and set up a simplification that's a little bit more straightforward. So anyway, notice that I can divide a 2 out of the top and the bottom. Those are gone. I'm going to have an x to the n plus 1 over an x to the n. I'm going to have a 3 to the n, and I'm going to have a 3 to the n plus 1 in my denominator. All right, so n of these will cancel n of these. That's going to leave me with just 1x in the numerator, okay? N of these will cancel n of these. That's going to leave me with just a 3 in the denominator, okay? Once again, there's no n left here, so as n approaches infinity, it doesn't affect the x. We need this whole thing to be less than 1, okay? Remember, you can take out the absolute value. We want x over 3 to be less than 1. We want it to be greater than -1. And this time you can see we're not going to get 1 and -1 as our final answers. We can multiply this by 3. We can multiply by all of these by 3, and we'll find out that x is between +3 and -3, okay? This one still will have a center. We're working with pretty simple ones here. This one will still have a center at 0. 0 is halfway between -3 and 3, but you can see we go up 3 from the center, we go back 3 from the center. So the radius of convergence in this particular case is going to be 3. Okay, so a little bit challenging, but hopefully the last couple of videos have helped.